If I asked you to name a microbe that's living in your gut, many of you would probably say E. coli. A lot of people say this. It's the best known of all gut microbes, but it turns out of E. coli is outnumbered in your guide about 1,000 to 1 by other species, many of which these are bacteria, protozoals in another example. Those are two that dominate that marine human gut. There are about 100 trillion microbes living inside you. We call this your microbiome. So it's like a little world living inside you. Actually, more like a universe. 100 trillion means if you took a plate of and planted it for every microbe living in your gut, that could fill a million football fields. But interestingly, other bodies have been adapting to life in modern society. We're losing a sum of normal microbes, and at the same time, there are very few diseases related to the gut that are skyrocketing in developed nations all around the world. And many of you probably know someone who suffers from obesity, diabetes, Crohn's disease, or allergies and asthma. Every one of these diseases that and many other related to our remedy are linked to a loss of health diversity in the gut. My lab got a first indication of this when actually we're studying non-human birds. We want to find out what happens to monkeys' microbiome when they move from jungle to a zoo. Does their microbiome change? Do they pick up new bugs? Do they lose some? Does it better or worse? We tracked two different species in jungle, one in Vietnam, one in Costa Rica, and the one this how we study microbiome in research lab. And what we found in the DNA in while these two species had totally different sets of microbes. It was like a fingerprint for species, but in the zoo they had lost most of that diversity and had acquired some other, and they was very curious. We've got these two different picture, a large tropical rainforest living in the guts of these monkeys. That's a kind of diversity. Then in the zoo they've lost diversity. Picture rainforest that been burned to the ground and taken over by few. That's more like the microbiome in captive pyramid. Now in meantime, many of the animals in the zoo are not doing They have issues with obesity, wasting, concentrating, bloating, and some of them were barely. Now, of course, we were very interested to find out what are these so-called invices that are taking hold. So went back to the DNA and what DNA told us. Every monkey in the zoo had become dominated by bacteria and protozoa, the same of microbes that we all have in our guts and marine groups. We want to find a way to visualize this, and we used some tools from molecular ecology to put all microbes we were studying on an axis. And what you're seeing here in the western, every point is a different animal microbiome. Every point represents the whole zoo of microbes, and the microbes that have a lot of to close edge that ones that very different. So this is showing you the two groups of wild monkeys are over on the left. At the top left are these highly cold red-shanked dog in Vietnam, and at bottom left are monkeys from Costa Rica. So you can see that have totally different microbiomes in the wild, and the same two pieces of the monkey in the zoo are converging. So their microbiomes change, they become much more similar to each other, even though these are so different geographical regions and they're eating different. Now we did study some what species of primate do you think about is an even more diversion from the wild primates than the captive primates. Marine humans. These are humans living in developing nations, so they were more different from the wild primates in the zoo. And the final group that we studied all the way on the right is people living in the USA. And when I saw the finger, the hair is up on the back of my neck, because one way to think about it, captive monkeys are like Americans, but the other way to think about it is that Americans like super captive monkeys, and they actually looking at finger of my computer screen that four of the red snakes had died in the zoo of Gaza. So some of these animals having the red molecules millions of now this brings us to human birth. Obviously, microbes in the USA are causing premature death as frequently major risk about obesity, a number of these other diseases, and this applies not just to people who have been living in the USA for many generations, but also to immigrants and refugees, who for most immigrants and refugee groups, they arrive in the USA healthy, and they high risk for obesity and diabetes and other Americans. And we discussed this issue with two groups that have been coming to the USA among who started coming from mid in 1970 as refugees from Vietnam War and the USA Secret War and Ukraine who have been coming from recently refugees. So we've been working for B with these local communities and clinic to study what happened to Hmong and Korean microbiome when people move from refugee camps and villages in Thailand to the USA. And what we found is that when people come to the USA from these groups, they lost large fraction of their microbe, so around 20%, and become obese, lost about a third of their microbes. So we noted moving is sufficient to cause a dramatic change in your microbiome, probably not for better. Are these microbes actually causing obesity, or is obesity causing a change in microbes? This is something that, and the evidence we have now in my lab, combined with evidence from number of labs around the world, tells us certain changes in microbe do lead obesity and a number of other modern kind of diseases. The good news is that microbiome can actually change. Unlike your own genome, it's a living, breathing thing, and the broad front of refugee happening to better understand how we can restore our microbiomes when something does using diet, using live microbes. And in fact, one of the next steps is collecting breathing so that they can be kept actual to potentially protect them as the marine society and protect future generations who are currently growing up to have increased risk. This I'm looking forward to a future where we have the tools that we need to restore and replenish our microbiomes, and in that world the monkeys will live having and so will